Yeah, so ground substance, first of all, it's a little confusing, but basically the connective tissue, there's three main components. You've got the cells that are obvious, right? They're the big circular things. You got the extracellular matrix, which is all the protein fibers and everything. And then the ground substance is basically everything else that's there. So it's mostly water, provides some support, a little bit of structure, and it provides a way for nutrients to move around. So if you're talking about the function, you're just talking about structure, attach cells together, and provide a place for nutrients to move. Attach cells together and provide a way for nutrients to move. Because it's water, so the nutrients can just float around, basically. Yes, so the function of fibroblast, are y'all listening back there? So the function of fibroblast is to make the protein fibers that make up the ECM. Right. So those fibers in the ECM, they come from fibroblasts. Fibroblasts make them.
Is the main purpose of the adipocytes just the storage?
Yeah. So store fats for energy. List and describe the three types of protein fibers. So the first one, basically we'll go in order of strength. So collagen's the strongest fiber in terms of, how much it would take if you pulled on it to break it. And then elastic, it's just like it sounds. Its main sort of unique function is that it's elastic. So it can provide strength, and then if you pull on it, it doesn't break, still holds something together, and it can go back to its original shape.
Is that like I know there was something else about like epithelial cells that can move, but is that kind of
Yeah, so the bladder would have a lot of elastic connective tissue.
And then what's the third one?
Oh, the third one, sorry, is reticular. And it's basically, it's the weakest. So it provides, some structure, some strength, provides some strength to places where you don't need a whole lot of strength. You want to be a little bit flexible, but still be attached together.
But it's made of collagen now?
It's made of a slightly different kind of collagen, which is confusing. So don't worry much about what it's made of, because then you get confused. Just what it does. So it's the weakest form of connective tissue. If you just need what are y'all doing back there? All right, anyways, anything else? Yes, Eliza.
For 1.1, for heat, would protection, secretion, and filtration be?
I think what I was coming up with, you have two of them, but basically be more specific about the protection. I came up with selective barrier, secretion, and protection from abrasion. Because, selective barrier is quite a bit different from abrasion protection. And you'll have different epithelium for different ones of this. And I want to make sure, did everybody see the shortened study guide? The new Chapter 4 study guide? Okay, make sure before you study for your exam, get that one. So I just basically took out, 3 or 4 things from part 1 and 3 or 4 things from part 2, so we could fit it in a day. So study from that one. Otherwise, you're studying a bunch of extra stuff. Should help. And then, when's your first exam? It is on Tuesday. Don't forget. Yeah. So you can have a good Valentine's Day and then study all day on Monday.
So what
So this one, it's going to cover chapters 1 through 4, the whole study guide for those chapters. So bold and non-bold, you want to be able to know. All right, so which of these is not part of connective tissue? Cells, ECM, ground substance, or all of the above are? So all of the above are. We're good. Which of these is not a possible shape? That's the keyword there. Shape of epithelial cells. Squamous, simple, cuboidal, or columnar? Simple, because that's an arrangement. And what is the arrangement of epithelial cells that results in many, many layers? So transitional, simple, stratified, or columnar? The stratified. Just like stratified rocks or something. And whose function is to secrete extracellular matrix? Is it fibroblast, macrophage, plasma cell, or adipocyte? Fibroblast. It's a good thing. I forgot who asked me about that one. So y'all should tell her thanks. Which type of protein fiber is able to stretch and return to its original shape? That's elastin. See enough. So if you did like that chapter better, did y'all like that chapter better than the other ones? That's a good sign. This is our first real anatomy chapter. You know, chapter 3 was about cells. Chapter 1 was sort of intro to stuff. So if you like that one, this one, that's a good sign. All right. Does this seem faint to you? Is that better? No. All right, so chapter 4 does have stuff about epithelial, connective, and then it starts to talk about muscle and nervous. I just took muscle and nervous out because they're their own chapter later, so why worry about them now? Just stick to these two. So epithelial, they're in sheets, and we talked about the functions, right? Protection from abrasion, secretion, and then selectively permeable barrier. They're very dense. There's lots of cell junctions. We're going to talk about those. That's like connections between cells. Because they don't have much extracellular matrix, they're almost always attached to some connective tissue, and that's called a basement membrane. No blood vessels, but it does have nerves in it. So you think about your skin, right? You have nerves in your skin. And that's epithelial tissue on the outside. So the only way that those cells can get nutrients is through diffusion from the connective tissue. And as we'll see in a little bit, connective tissue is full of blood vessels, which means there's lots of blood and nutrients going through connective tissue. So those nutrients just leave the connective tissue and diffuse over to the epithelial tissue. You can kind of see that here. So what kind of cells are those, by the way, if you had to guess? Yeah, so this is a simple columnar epithelium. So a whole bunch of epithelial cells, but just one sheet. And then this is the basement membrane, and then the connective tissue. So the basement membrane is between the epithelial and the connective. So it's a strong proteinous layer. And here's where your nutrients come from, and they'll just diffuse up through there. And then the waste diffuse down and here to the blood vessels and get taken away. So your skin, which is actually the next chapter, it's both. So the outer part of your skin is epithelial, and as you get farther into the skin, it becomes connective. And we'll go through all those layers in chapter 5. All right, and just like you did on the quiz, the shapes, squamous, which are like little pancakes, cuboidal, cubes, 3D cubes, And then the columnar, basically a long column rectangle. What is the 3D rectangle called? Somebody know? I can't remember. That's like 4th grade, but I can't remember. I think it might be called a rectangular prism, actually. But anyways, 3D rectangle. And then simples in one layer, stratified, a whole bunch of layers, pseudo-stratified, just like it sounds, sort of in between. So it's not simple, it's not really stratified, it's sort of stratified.
So can like one tissue be made of different types? Or one, like can like simple and pseudo-stratified be in the same type of structure?
They could be close together. So like, for example, yeah. So for example, if you're talking about, the path air takes to get to your lungs, it's going to pass through stratified and then pseudo-stratified and then eventually to simple. But in general, if you looked at one specific spot, like the lining of one blood vessel, you're only going to see one type of epithelial tissue. All right, so you can have different combinations of layers and shapes. For simple, which is that one layer of cells, you can have simple squamous, you can have simple cuboidal, or you can have simple columnar. Pseudostratified, the only kind of pseudostratified is columnar cells. For the stratified, you can have stratified squamous, stratified cuboidal, or stratified columnar. And then transitional is its own. I think I took that one off the study guide, if I remember correctly. Where's my thing? Yeah. Transitional means it can change shape from basically from squamous to cuboidal. And the cell that can do that is in the bladder. So when your bladder expands, those cells go from cuboidal to squamous, and when it's emptied, they go back to squamous. That's the transitional epithelium. Kind of interesting. All right. And if you want like a nice slow review of all of those different types of tissues, where they're found, you could definitely go there. It'll help. Instead of me just talking at you about them, I'm going to have you do a little activity with them, which you'll see in a second. First, let's talk about just one to kind of give you an idea of what you're going to be looking for. Because the main thing I want y'all to know about these different kinds of epithelial tissue is where you find them and what they do. So examples of where they are and their function. And so start with stratified squamous. This is the outside of your skin or the lining of your mouth, for example. And if you see, we've got a whole bunch of flat cells. And I don't know, I could count almost 20 layers of cells in there. So each little circle is a nucleus. And you can see it's got a little round cell membrane around it. So 15 or 20 layers. It protects from abrasion. Because let's say you rub your skin on something and you just take off everything above that ruler, nothing bad happens. You've got 10 more layers that can just push their way out. And in fact, do you see any blood vessels in there anywhere? So if you just scrape yourself a little bit, you don't bleed, right? That's your gums are the same. Mm-hmm. Lining your mouth, the gums. I would say your skin probably has more layers than your gums. Your gums seem a little more sensitive.
So if it protects against pathogens,
Mm-hmm.
does this mean like your skin's like a protection barrier?
Yeah, so for a pathogen to get through here, these cells are packed really, really tightly together. They're attached really tightly, so there's not really any space for pathogens or It's a lot harder for anything to get through this. Toxins, chemicals. Well, fire could get through eventually. Right, and we'll talk more about the skin in chapter 5. So, how do you think the structure of stratified squamous epithelium supports its function? Things. Oh, let's see what everybody voted for here.
No, I'm on your team.
All right, let's see what we got. B, C, D, E, about as even as we can get. So the answer for this one is B.
Oh, that's what I picked the first time.
And you'll see this is kind of a recurring theme in anatomy and all sciences, that structure sort of determines your function. And so every chapter I'll have at least a couple of these sort of questions. It could be what it's made of. It could be the shape. It could be the arrangement of the cells. So let's see, C was the second most popular. So that one's tricky, but no epithelial tissue has lots of collagen.
What? It doesn't?
It doesn't.
Oh.
It has very little extracellular matrix. Connective tissue has all the collagen. So that's actually a false statement. A, that's not true. Squamous cells are not very good for absorption. They don't have, yeah. You actually want columnar cells for absorption.
Why did it say your skin is like the quickest way to absorb?
So probably because there's so many blood vessels close to the skin. I mean, what are they comparing it to? Swallowing something? So I mean, think about how much time it takes for you to swallow something, go through the stomach, get to the intestine.
Oils or anything that they say
Mhm.
or people get chemicals on their skin so they work less because you can absorb so much through your skin.
Yeah. I guess if your skin was not stratified squamous, you would absorb it even faster.
So like if it was columnar, like
Right. Right. You'd absorb it even faster than it would otherwise. And then it doesn't really matter so much that they're flat. If they were simple squamous, your skin wouldn't work at all. It really needs to be stratified so you can scrape away layers and nothing bad happens.
No, I was just thinking like if they're really flat, like you were saying, the collagen's like so tight that there's really no room for like it helps to support because they're like so tight together, like they should pack. That was
Yeah,
my argument.
I could see it a little bit.
It was a super good argument. It was wrong twice though.
Well, it's a reasonable argument. I'd say this one's B's 90% true, maybe D's 10% true. Wouldn't say it's completely false. But again, I make these clicker questions for you to think about stuff, not so much test questions. All right, so the way you're going to learn about these different tissues, types of epithelium tissues, is the following. So I'm going to give each group a different tissue type, and their job is to find two places that it is in the body and two main functions for that type of tissue. So y'all got all those? So on the test on Monday, basically that would be like a short answer question. So as long as you can tell me two places you find each of these and two functions, you're fine. For each one. So it's some stuff to memorize, for sure. All right, so let's go ahead and move on. So basically that was a whole bunch of the lining. Hey, Adriana, do you want to go back? Do you want to join your group again? All right, so the other kind of epithelium is the glandular, which we'll talk a lot more about when we do endocrine system in 202. But basically, we said one of the functions is secretion of epithelial tissue. That's the job of the glandular epithelium tissue. And most of the time, it's either cuboidal or columnar. And it makes hormones, basically. So glandular epithelium makes hormones or other secretions, like tears and everything else. Sweat, which we'll talk about next time. So all your tissues, especially the epithelial cells, are connected to each other in different ways. We're going to go through 3 of them right now. So we're going to talk about the adherens, the tight junctions, and the gap junctions. And just remember that's 3 different kinds of connections between 2 different cells. Maybe. It's a lot slower than normal. And one thing to point out before we start is that you could have all 3 of those junctions between the same 2 cells. So like one cell, like, whoa, what's it doing? I thought it was paused there.
Nope, not today.
So tight junctions, adherens, don't worry about desmosomes or hemidesmosomes. So we're going to do, where's my pause here? So we're going to look at gap junctions, adherens junctions, and tight junctions. And if you see from up here, these 2 cells are connected by all 3 of those. So it's not like you'd only find one in a cell. They could have all 3. All right, so let's start with our tight junction.
The tight junction is an area where the plasma membranes of adjacent cells are fused together. These junctions protect underlying tissues from harmful substances by restricting the movement of substances, like hydrochloric acid, in the spaces between cells. Tight junctions are found in tissues lining the surface of organs and body cavities, such as the stomach, intestines, and urinary bladder.
So if you notice, we had, there's epithelial tissue lining all of those structures, and those cells have tight junctions between them. And the way I remember tight junction is that it's watertight. So it doesn't let anything past it. It's a watertight connection, which is good because you don't want hydrochloric acid coming out of your stomach into your abdomen, or half-digested food just leaking out there a little bit. Just, collecting the abdomen a little bit. So that's where tight junctions are so important. All right, next up.
Adherens junctions are created when transmembrane proteins, anchored to a dense plaque of proteins inside the cell, connect the adjacent cell membranes together. Additionally, microfilaments extend from the plaque into the cytosol of each cell. The dense adhesion belts help resist separation of epithelial tissues.
So this is what you'd have like between those cells of the skin to keep them connected together. So this is your adherens junctions. So it's a structurally strong connection, but it's not watertight. water could still kind of squeeze through there or other materials. But this one's much stronger than that tight junction. Like you could pull on these two cells and they wouldn't come apart. If you just had tight junctions, you could very easily just pull two cells and they would just come apart. That makes sense. So they have different functions there.
Are there tight junctions just like do those form just because there's so many layers, or the shape of the cell, or does it just?
Most epithelial cells have at least some adherent and some tight junctions. Some of them have more of one than the other, but you need to have at least some of each of them probably.
Oh, okay, so like your digestive tract would have.
Lots of tight and some adherents.
Okay.
Good question. All right, so skip those and we'll look at our gap
The
junctions.
gap junction is an open communication channel. Transmembrane proteins, called connexons, join together to create tiny tunnels that form gaps between the adjacent membranes. Gap junctions allow ions and other small molecules to pass freely from one cell to another. Gap junctions also allow electrical impulses to pass rapidly from one cell to another. Gap junctions are particularly abundant in some types of muscle tissue.
All right, so these are just like what they sound. They're little holes that connect two cells together. They're gaps. So we've got, like that's a transmembrane protein, and that's another transmembrane protein on the next cell. And they connect together to make one channel through there. Really important for signaling, especially in like the heart. So basically the signal to start a contraction will come from one side, and it's calcium. And those calciums are able to travel from one cell to the other and immediately activate. Just moves through all of them one at a time. And that's the fastest way to send signals. Much faster than sending something out of the cell, letting it get brought back in, sending a hormone. This is way, way faster. Just have a gap between there so the signal can just go straight through as if it was one cell. It's much faster that way. So that's the old gap junctions there.
Where would those be?
So muscle and nerves.
Sorry.
Sorry. Muscles and nerves. Not really in epithelial tissue there.
I read that. Registered in my brain.
All right, so let's see. What's don't choose C or D. So I said don't worry about those. So A, B, or E. So what lets them stretch without tearing? All right, so E is the best answer there. It is the adherens that give you protection from stretching and tearing. So tights for preventing things from leaking past you. You can kind of think of it if you're like, putting two pieces of wood together or something, and you just put a little piece of tape on each side. That might be watertight, but if you pull it, it's immediately going to come apart. Whereas the adherens would be like if you put a bolt through it and tighten down. You could pull on it all you want, and the two pieces aren't going to come apart. And I guess the gap would be like drilling a hole between the two of them. Something in the hole for the membrane protein. Yeah, it's probably a better analogy just for adherens and tight. Just like a hole. All right. Any questions about epithelial tissue before we go to connective? All right, then let's move on to our second. So there's definitely more connective tissues, but since we're shortened, I just had to pick out a few to focus on. So the loose that I picked out for us to learn about is adipose tissue. There's also dense connective, which basically makes up your tendons. We're going to talk about some cartilage. And bone and blood are actually considered connective tissues, which is really weird, especially because blood is not connective, but it comes from the same original stem cells. So we've only got 4 kinds of tissues, so they had to put blood somewhere, basically. But we're going to talk about bone and blood in their own chapter, so I don't really need to worry about those at the moment. We'll stick with the connective tissues that sort of fit their name. So as we mentioned, all the connective tissue is made of cells and ECM. And it's pretty different from the epithelial. So lots of blood vessels, lots of nerves, except for your tendon and cartilage. There's actually no blood vessels in there. They're close to them, but not like, it's not like in the tendon itself. It's kind of attached to it.
Is
So,
the ground substance part of connective tissue? I thought at the beginning you crossed.
yeah, so ground substance is there too. For whatever reason, our textbook calls it 2 main elements, even though I would say there's 3. So yeah, cells, ECM, and ground substance.
So like on the test, if we did put the ground substance in there, you would accept that?
Yeah, because I can't really, the book says it right there. I can't say that you should not know that. Because technically they'd say ECM is made of fibers and ground substance, calling them a separate thing. But I don't know. To me, it's still different. All right, so look at this picture here. Seems confusing. All these circular things are the cells of connective tissue. Any of these colored lines, like the blue, the yellow, that's all the different fibers that make up the ECM. And then the sort of background yellow, that's the ground substance. So it kind of surrounds everything, the ground substance. I'm trying to think of an example. Like if you made, fruit jello or something, the fruit would be the cells and the fibers, and then the jello part would be the ground substance. It's just like surrounding everything else, and it's mostly water. It's kind of squishy. Yeah, kind of like cytoplasm in the cell surrounds everything. Ground substance surrounds everything in the connective tissue. Yeah, so it's like you need something there. You don't just want to have water there.
Okay.
So you need something that's kind of squishy, let water move around, let nutrients move around. I like the fruit jello.
Now I'm hungry.
All right, so what cell type actually secretes those extracellular matrix fibers and sort of maintains it, keeps the connective tissue as in the right shape and everything. All right, so if you turn your page there, I'm just going to go through a few of the connective tissues. And once again, we're going to find 2 places in the body and 2 functions. I'm just going to go through it in the interest of time, since we only got 20 minutes. If we had 2 days, I'd probably make you do it. I think I really got this computer upset today. All right. So you want the volume on? I don't want the volume really. All right, so here's all the different ones. I just picked out, hopefully there's 4 in the study guide. I'm just gonna stop. So we'll start with a type of loose connective. And we'll do adipose tissue. So adipose tissue is obviously where you have big fat stores. And it also provides cushion. So, for example, there's a whole bunch of adipose tissue behind your eyeball, so that if somebody smashes your eye, it kind of has some cushion behind it and doesn't just squish and burst or something. So where in the body, you can pick anywhere you want where you store fat. Does anyone want to name a few? There's around your heart. So hips, abdomen, common places. You can put behind the eye. Interesting. If you write love handles on your test, I'll still give you credit. That's fine. If you really want to.
That's part of your abdomen.
And then functions, I'd say stores fat, provides cushion and insulation. So that's that one.
But around your organs, right?
Yeah, it's around most of your organs too. Yeah. All right. Let's head back here. What's next? Dense regular. Oh, and one thing I wanted to point out on here, see how C just looks like purple at the moment. So dense connective is almost only collagen. It's just tons and tons of thick, wrapped up collagen fibers, and there's 4 little cells, and a whole bunch of collagen. So almost, this is true for most connective tissue. It's mostly ECM, not a whole lot of cells. And of course, you'll look at this under the microscope too. And you'll think it's not focused, right? Because it just looks so sort of fuzzy.
Fibroblasts is the actual name for the cell.
Fibroblasts are the name of the cell. So these 4 fibroblasts, from when you were, a fetus, they've been making this collagen to form.
So you only have 4 ever? Or do they like renew?
Well, this is just one example, but you do get new fibroblasts all the time.
When we start aging, they stop. That's like what we reach and stuff.
That's one idea. So you have less collagen giving you wrinkles, or that's one idea at least. All right, so some locations, tendons and ligaments is probably the ones I'd stick to, because that makes the most sense. These are little pads in your knees and your pelvis. So they're places that take so much force and pressure that you can't just have cartilage there. You have like a little piece of tendon. So your meniscus, heard of your meniscus? That's a kind of dense connective tissue. Aponeurosis. Yeah, I think there's one on each side of your knee, lateral and medial. Yeah, so those go right between the bones. Down there. Right. So aponeurosis they're just fancy tendons. They're not really made to stretch or move so much, but just be there for, more than cartilage would give you. What's next? Hyaline cartilage. Oh, attachment of bones to bones or bones to muscle. Resist stress. Very strong in terms of pulling. Like think about how hard it is if you you know, if you get like a chicken quarter and you're trying to like pull a leg off before you cook it, you can't probably, right? Without a knife, like it's nearly impossible. You actually have to like cut through it. So it's pretty impressive. That's a little chicken leg and you're putting what, like 80 pounds of force and you still can't pull it apart. So think about what ours can take. Ours are a lot thicker. All right, so I'm gonna do a few kinds of cartilage. First up is our hyaline cartilage. And so you can see there's quite a few cells in there all throughout. And the hyaline cartilage gives you flexibility, support, absorb shock. So these are between your joints.
So do you want us to list 2 joints that they're in, or are they in all of them?
You can pick 2 joints, like elbow and knee or something. It's not a bad idea. So where those 2 bones meet, you could see in, trying to get it there, in the blue is the cartilage, the hyaline cartilage, so you don't want your bones banging against each other. So in arthritis, that's the cartilage you're losing.
So is that like what's between your ribs?
Yeah, so another place, so your ribs, actually when they come around to the front, we're gonna do this later, but it's not bone all the way.
Yeah, I kind of see.
It stops and it switches from bone to cartilage. And that helps so that when you can take like blows to the chest without your ribs shattering and, you know, your heart being smashed or something.
So is cartilage made of collagen too?
Yeah, so it has collagen too, but not as much. And it's got lots of ground substance. So actually the way it's able to absorb shock, it actually acts like a hydraulic fluid. So it's full of water, and you can't really compress water, right?
Yeah.
So it just kind of absorbs that and then releases it.
So if I just try everything, like a knee and elbow joint.
Yeah, that's fine. 2 different joints. So, right, and then we've got one more. Which one did I put on here? Fibrocartilage. All right, if you notice, this fibrocartilage has, see how it's kind of striated? It has more collagen than our hyaline. And its support, and it resists compression and shearing. I can't breathe. But once again, all that dark blue is extracellular matrix and ground substance, and just these little black dots are the cells, the fibroblasts, which are specifically called chondrocytes in this case, but they're still a type of fibroblast. And I just told you all totally backwards. This is the meniscus. All right, I guess I don't remember what that aponeurosis was. I thought I looked that up yesterday.
Hey, it sounded really good. I totally
I know.
believed you.
I know. I'll have to look that one up again. So anyway, the meniscus, that's basically you don't want to just have regular cartilage there, hyaline cartilage, because it takes too much force. So instead, you've got the fibrocartilage that has more collagen. It can't move so much, you know, like stretch and go back, but it can take tons of force. So in your knee, on the edges, where your pelvis meets at the base, takes a ton of force and pressure. So you have it there. And then another important place is between the discs, between your vertebrae.
Isn't that kind of what isn't that what the discs are?
Mm-hmm.
And that, like, when you herniate a disc, it's those.
Yeah, so these discs, we'll talk more about their structure, but a big part of them is the fibrocartilage. There's a few other things in them too, but we'll do that when we do the bone chapter. Yeah, because think about how much weight's on your spine all the time, right? You know, 50, 60, 70 pounds at all times. So, fibrocartilage. All right, so that's those. Again, you'll get some extra review on those in lab on Monday. It's different ones. All right, so we got 10 minutes. Here's just some extra slides if you want to look those over about hyaline and fibrocartilage. But I want to get to the last few things. So what is different between different connective tissue types, do you think? All right, so the answer to this one is F there. So it's all of them. So first off, type of cells present. May not be something I went into too much, but there are different kinds of fibroblasts. And they make different amounts of ECM. So like, you might have one fibroblast that makes tons of collagen. You'd find it in the dense regular. You might have a fibroblast that makes mostly just ground substance and a little bit of reticular tissue. You might find that in the adipose tissue. So the type of cells are what start those tissues from being different, because they're the ones that are in charge. So they'll kind of develop it and start it. The ground substance, that can be different. Could have more water, less water. Technically, bone is mostly ground substance. So is cartilage. Right, but it's like hard mineral calcium salt. Relative amounts of different ECM, that's true. A little collagen, a lot of collagen, a lot of elastin, not very much. All kinds of different combinations. To it? The reticular fibers. And then their main function, that's why they're different. If you need to hold two bones together, you better have lots of collagen. If you need to cushion two bones from banging into each other, you need to be mostly water or viscous ground substance. All right. So we're going to work on those bring these on Monday. So we'll take 10 minutes at a lab to work on those last two questions. But I do want to talk real quick about serous membranes. We talked about those in chapter 1, if you remember. The peritoneum, the pleural membrane, the pericardium. And what a serous membrane is a combination of epithelium and connective tissue. And it lets organs move without friction, like you'll learn in chapter 1. And it kind of protects them from outside things getting to them. So like if you have some kind of cut, like in your abdomen, it has to get through the skin first. That wouldn't be all that big of a deal. But then if it got through the peritoneum too, then that's when you're really having issues. So it's kind of extra layer. Yeah, so it's like extra skin over organ, but technically over cavities.
Okay.
And so you've got, like, for example, if you looked at the serous membrane around the lungs, you remember there is two of them, right? The parietal and the visceral. So this would be just one of them. I don't think it matters which one. But the layer that touches the lungs, for example, is epithelium. And then there's a layer of connective tissue. Because epithelium blocks things from moving through, but the connective gives it that structural strength that it needs. Otherwise, those cells would just fall apart. So you get the best of both of those tissues if you put them together.
So then the fluid is so like each layer has two layers too.
Right. So if you're talking about the pleural membrane, you'd have your lung, then you'd have epithelium. Let's make it a color. Then you'd have a layer of connective. Then you'd have, what was the name of that fluid that was between? So then you'd have some serous fluid. Spelling it wrong. And then do you think it's connective or epithelial next? Since it's got this fluid here, you're actually going to have the epithelium next. And then, wait, that's the wrong color. So an epithelium layer, and then another connective layer. So that's one serous membrane, two serous membranes. And each one's got the epithelium and connective.
So then now this one, right?
To what?
The two on the inside of that be visceral.
Yeah, this would be visceral. And this would be parietal. And if you're talking about the lungs, it's the visceral pleural, the parietal pleural membrane. All right, and just one last slide about tissue repair, even though we mostly already talked about that. Especially in those epithelial tissues, those cells are they're not all that strong, they don't live that long. They're kind of made to just be constantly replaced. And so the way you replace them is to have stem cells divide. And then those stem cells, they make a bunch of new cells that can replace the dead cells, the ones that got scraped off your skin, or you ate that piece of chip and you didn't chew it and it scraped 1 million cells off your esophagus. You just make some new ones. It's okay. It's no big deal. All right. So bring those assignments on Monday. We'll do those last few questions, which are the last 2 things on the study guide. And then we'll do all the histology. Yeah, you'll have a pre-lab quiz due on Sunday night. Put it up today.